Hi everyone. Today I'm excited to discuss the outcome of my project in the Managing ML project course, which is a machine learning product called Polaris AI. I will discuss the machine learning solution I have designed from the perspectives of opportunity evaluation, business understanding, solution validation plan, system design, and potential risk in production. The goal of the product is to improve risk assessment efficiency in payment platform seller onboarding process through data-driven automated evaluation. You might wonder, with a plethora of cross-border payment products available today, why do we still need to do this? The current user onboarding approval process for financial products is cumbersome and time-consuming. Staff members are required to sift through large volumes of documents, often in inconsistent formats, to evaluate risk levels. Additionally, these documents may be stored in different systems, which further impacting the efficiency of the review process. So how can machine learning improve this situation? ML can be utilized to automate the approval process, which includes integrating documents and providing an overall risk score and potential risk factors based on the attributes and weights of these documents. By developing and implementing effective data analysis model, the results generated by the model can enhance the accuracy of assessing risk levels. By analyzing data from different dimensions, we can also assist staff in quickly adapting to the impact of external factors on risk assessments. From both an economic and business perspective, an effective risk assessment model improves the efficiency for staff and reduces their cognitive burden, thereby lowering manual operation costs. From a product standpoint, an efficient approval process significantly shortens the time it takes to assess user onboarding applications, thereby enhancing the user experiences. While achieving high data adaptivity and accuracy, we can also reduce the rate of misjudgments, avoiding potential customers being rejected from onboarding due to data scarcity and cognitive factors, thereby increasing the success rate of onboarding. In this project, I have adopted the CRISP-DM framework to conduct the business understanding process. Our product is targeted towards operation and risk management personnel responsible for assessing user risk ratings and making decisions on user onboarding. The problem statements our product addresses is that the process of evaluating user risk levels is cumbersome and time-consuming, requiring retrieval, parsing, and analysis of different formats of files from various systems. Solving the above problem is crucial for our users because unstructured information system increase staff cognitive burden, decrease manual review efficiency, increase operation costs, and ultimately decrease the user experiences for our end users. In the current landscape, some products in the same industry are attempting to integrate information from different channels onto a single platform and leverage risk scores provided by third-party data providers to address the aforementioned problem. However, staff still need to spend tons of time reviewing those information piece by pieces. Results from feature analysis and business research indicates that there is a significant potential for automation in the auditing process once the platform has established a evaluation metrics, such as the impact of different types of information on user risk levels. Additionally, retraining staff after updates to this evaluation metrics is very time-consuming. Transforming the assessment process through ML-based data automation directly enhances efficiency, accuracy, and success rates, thereby achieving business impacts such as user growth and revenue growth. At the same time, several constraints need to be considered. The ability to access high-quality, authoritative, and timely user credit and risk assessment data is a critical factor in the success of the model. Given the diversity of payment products, B2B transaction scenarios, dynamically adjusting the weights of different indicators and the correlations between different features when assessing the user risk ratings across different industries is necessary. Therefore, ensuring the model's complexity and interpretability is a significant challenge. The most intuitive outcome metrics for the model and the completion time of risk assessment, with a planned reduction of 35%. At the business level, the success rate of user onboarding is also associated with outcome metrics, with a planned improvement of 20%. For the output metrics, I will use the mean square error of risk score, which directly explains whether the model provides objective and accurate risk assessment results. The key factors related to the model includes user identity data, geographic region data, industry type, financial product type, user credit ratings provided by third-party providers, as well as the cybersecurity data such as browser fingerprints and IP addresses. The both data have strong correlations. For example, the risk levels for the same industry may vary across different regions, and the regulatory levels for the same financial product may also differ across different countries and regions. Therefore, feature engineering, hyperparameter adjustments, and weight training play a crucial roles in the success of the model. In real-world scenarios, the model will calculate the overall risk assessment score for users based on multidimensional user data and their respective weights. If there are high-risk areas, the model will generate corresponding warning messages to the operators, so that the human auditors will refer the information provided by the model to assist in making decisions on onboarding application and assessing user risk. For this project, I have adopted an agile development framework for both model development and business model validation processes. Firstly, we will align the product objectives and business model feasibility through interaction prototypes, whether it is high fidelity or low fidelity, and also create some presentations with stakeholders, business sponsors, and users. Next, we will collaborate with industry experts and the data team to conduct feature selection processes and develop a mock-up model containing a small subset of historical data. Subsequently, we will validate the model's effectiveness through focus group sessions. In the next iteration, we will develop a heuristic model using real data and conduct internal testing to further validate the model's feasibility and effectiveness. Following that, we will develop a simple or a base model using real data and iteratively optimize it through algorithm comparison, hyperparameter adjustments, and other methods. In subsequent iterations, we will continue the aforementioned iterative process. We will then deploy the model into the production environment for A/B testing and iteratively optimize the model based on user and stakeholder feedback. Considering that our product is an online platform and specific use case, the model will indeed be cloud-based. We will utilize offline learning for model retraining, which will be done on a schedule using updated data points. Given the time sensitivity of the onboarding process and risk assessment results, the model will employ online predictions. When deploying the model into the production environment, we will face several potential risk factors. First, there is the risk of training serving skew. The training data may not include specific types of cases, leading to degraded model performance, such as bias or overfitting. We can address this issue by monitoring model incidents, accessing more data providers, and conducting planned retraining. Additionally, we can suggest a human reinforcement learning mechanism, where human employees provide feedback to dynamically adjust model parameters. Secondly, latency is a concern. Considering the direct impact of inference results on end-user experiences, latency in onboarding assessment waiting time is crucial. The performance of the model and the architecture of the data pipeline significantly affect inference time. Moreover, data drift is another important risk factor. Changes in external factors may significantly affect the model's accuracy, such as updates to user credit ratings by third-party providers. We also need to ensure the timeliness of data and regularly retrain the model to address these changes. Concept drift is also significant. Changes in macro factors have a significant impact on the weights of different risk ratings and indicators, such as the changes in risk ratings for a particular region or industry. We also need to retrain the model and adjust model parameters after adjusting the risk assessment strategy to ensure the model's effectiveness. Another factor to consider is adversarial reactions. Pattern learning, malicious data spam, and DDoS attacks are all considered as the adversarial reactions, and they can significantly impact model performance and contaminate training data, and also increase the server loads. As a result, we need to have advanced data filtering techniques and cybersecurity measures to prevent these attack methods. Lastly, we must also address data privacy concerns. Given that personal identity data and financial data are very sensitive, we need to encrypt and anonymize sensitive data during data processing and analysis. That's all for my product concept. Thank you very much for your listening, and feel free to drop me a message if you have any questions. Thank you.